Welcome to Mind of a Scientist. It is my great pleasure to introduce Tatjana Ellis from the Monterey Bay Aquarium Research Institute and founder of a podcast about computer science and marine research. Thank you so much for being here today.
Yeah, thank you so much for having me. Hi, everyone. Like Milo already said, I'm Tatjana Ellis, and I am actually still a student at Cal Poly, a double major in marine science and computer science. And I'm working together with Mbari on an outreach project right now for marine science. So if any of you don't know, Mbari is the Monterey Bay Aquarium Research Institute. So they're actually at the frontier of combining engineering, like mechanical or software engineering, with life sciences, biology, chemistry, like anything you can really think of, and combining all of these fields together in order to advance how we study and understand the ocean. So it's a really, really amazing facility, and I definitely recommend checking it out after this presentation. And you can also find more at mbari.org. But pretty much what I'm doing for my project is I'm trying to bring awareness to the opportunities that exist in using computer science in marine science research, or even overall in research. Because many people don't know that actually how important computer science is in the research field, especially nowadays. So to do this, I interviewed some staff from Mbari, specifically software engineers, and then made podcasts out of them. So there's going to be 3 episodes in total of different software engineers that I interviewed at Mbari. So that is pretty much my goal with this project, is to bring awareness to this and to share it with everyone so you too can know about these amazing opportunities that exist and even can get involved if you want to, because it's really, really amazing stuff that is being done. All right, so actually I wanted to share even a little clip of one of the podcasts with you quickly before we continue talking. So I'm going to share that right now. So this is my podcast. So I'm sure the link will be sent later on. Like Milo can send it to all of you, or even for those watching on YouTube, probably it will be in the description. But this is the podcast that I'm doing, so you can find it here. And then I was going to show a clip actually of the second episode with Brian Kieft. So Brian Keefe, for background, he is a software engineer at Mbari as well. And he's actually in charge of doing, like building a lot of the devices, the AUVs that get sent out. And AUVs are automated underwater vehicles. And pretty much they're like self-operating vehicles that go and drive around the ocean. So really, really awesome thing. So he's in charge of programming a lot of it, writing the embedded systems, like deploying them, retrieving them, like that. So it's really, really cool work he does. And then I wanted to share a clip where he actually talks about some of the funny things that he's experienced at his work with everyone. So I'm going to play, and please let me know if you can't hear it.
This superhuman team that's better than ever. So
yeah, that is really awesome. And pretty much that allows us to go even further and do things or collect data that humans themselves can't do, right? So it really helps advance the research field, which is really, really amazing.
Exactly.
But then I know earlier you mentioned so many different jobs that you do, right? So much variation. So this might be a really difficult question to answer. But do you have any experience or project from your work that you found especially meaningful that you would like to share?
Yeah, totally. Actually, like meaningful and funny and hilarious, kind of all combined.
I'd love to hear that.
I mean, yeah, let's see. So, like, just kind of thinking back here, being out on a frozen lake in Maine at 3 in the morning in sub-zero temperatures, on a four-wheeler, or like seeing orcas swimming by on a nice winter afternoon after a successful mission. There's just all these fun little memories that you get to have. One of the instruments I designed ended up in the London Museum of Science, and I got to go there and take a selfie with it and see it on
Wow.
display. And after a successful, design and then field program and stuff. One time I was off the coast of Senegal on an island, hitchhiking in the back of a truck and down this dirt road. And on my phone, I had an autonomous system in the Atlantic that I was driving and in the Pacific. And I was driving both of these at the same time from my phone on this dirt road in this back of a truck. Scuba diving in Spain on ocean observatories with colleagues there. Just all sorts of great. And I guess maybe the most meaningful things are working with all these other great people and the other institutes and agencies that we get to work with, and just kind of changing the way they do science and learning from them and what their interests are and trying to, I don't know, just help them achieve their goals. Sometimes we lose things. I've got great stories with involving helicopters and airplanes and lots of trespassing and stuff like that to find assets. One time I got bit by a black widow spider on my porch answering a call at 2 a.m, dealing with
Oh
an issue
no.
offshore, just all sorts of random, funny, interesting things that happen in this line of work. So it's
That's
yeah,
really
pretty endless
amazing.
list.
I know you've been. Yeah, I thought that was just a fun little clip to share of his name's Brian Kieft. Like I mentioned, very amazing researcher there. All of them are. So they're just the funnest people to work with, honestly, when you get into the research field. And there's so many more stories too. Like you even look up, there was a time when some fishermen held an AUV hostage. They found it in the ocean and were trying to bribe Mbari to get it back. But of course, the AUVs have location sensors, so they didn't really get very far with that. But there's just so many interesting and funny things that happen when you're in this line of work. You never really know what's going to happen, right? So it's a really exciting time, you would say, a lot of adventure. Right, for me too, I've actually worked at Mbari twice. And I work more on the computer science side of things. So I write a lot of code, I do a lot of data analysis, things like that. But I remember, especially working at Mbari, this kind of research facility, it's very, very spontaneous, you could say. So I'd be there writing code, and then Brian would run into our office, like, we're deploying a vehicle right now, come on. So we drop everything and run out and go on the Paragon to deploy a vehicle. So it's just really, really awesome work. And I think any of you, if you're interested in this, please look into it more. It's like really, really cool stuff that is being done. But then also I wanted to mention a bit more about what I do specifically, right? So besides these podcasts, I've actually been doing research pretty much since freshman year. So going into Cal Poly, I was determined to get a double major and to integrate different fields. But then I've pretty much found a passion and love for computer science and marine science because I love the ocean, I love the planet, I want to help save the planet. So that kind of motivated me to go for it. But then doing that too, I met a lot of amazing professors, amazing projects that needed that kind of integration, right? I don't know if any of you have heard before of like any projects integrating both fields, like computer science and research. So I wanted to share a few of the projects that I have worked on so you can understand a bit more like what can you actually do with it, right? So then I have a few pictures to go along with it too. So I'm going to share my screen again. There, can everyone see this? Yeah, thank you. So first of all, Cal Poly actually has their own pier. So here are a few photos of it, which is really, really awesome. They have a research facility at the end of the pier, like different devices, equipment that's taking data continuously. So it's a really amazing place to work. But then first of all, the first project I worked on at Cal Poly was the Arduino project, which was with Dr. Tomanek's lab, Lars Tomanek. And pretty much what they had us do was they wanted to code these Arduinos to connect to 4 separate aquariums. And then each aquarium would simulate different natural conditions of the ocean in order to test different stress factors like food stresses or heat stresses. So we had these Arduinos that were hooked up to a bunch of pipes and cords and everything. And on the right, you can see the actual setup. Just here, the project had already ended, which is why the aquariums actually closed off, right? But we had different sensors that pretty much simulated tidal wave action, right? We had sensors that upped the heat of the aquarium, that automatically dispersed food at certain times, that turned on and off the lights to simulate day and night time. So all of this was being done, and we pretty much coded it using these Arduinos, which on the bottom left, you can see a photo of part of the setup of the Arduino board. And so this little Arduino was actually in charge of managing all of these different responses and interactions. Yeah, so that's actually a really amazing project to show how even something where they're studying biology, right, life sciences, like how do different organisms react to heat changes and food changes, actually that too requires computer science work, right, and computer scientists to help make that project happen and help make it successful. Right? So then the scientists didn't have to sit there 24 hours manually changing the conditions. Right? So it was really, really a meaningful project. And then also I want to share a bit of some of the work that I do, because I've been also working with Dr. Ryan Walter for the last 4 years now. And we've been working on analyzing CTD data and temperature and satellite data in order to quantify what's called intrusion events and understand upwelling better. So here's like me presenting a symposium about this. And then on the right, you can see what a CTD looks like. So a CTD, it stands for conductivity, temperature, depth. And it's pretty much this gated, this gate that has a bunch of different sensors attached to it that collect data. So then we have a CTD located at the Cal Poly Pier that has been taking data continuously for over a decade now. So we have a lot of data to work with. And then what I do is I analyze this data, I help visualize this data, like plotting it, making it visual so we can really see what is going on at the ocean. Right. So there too, it's a very important job to be able to write code and to integrate that. And then also I mentioned I worked at MBARI twice. Oh yeah, this is an example of some of the data that I helped plot or analyze, like one example of an intrusion event where you can see the warm waters going into the shore. But if you have more questions about what's going on here, definitely I'd love to answer that after. Yeah. And then at MBARI too, first of all, this is MBARI, the bottom left picture, very beautiful, amazing facility right on the beach. Like literally you're in your office, you walk out the door and you're on the beach, just really great. But I was working mostly on code, so I don't have too many photos of that. But what I did was I worked first at my first internship on an Argo project where Argo floats is a network of floats in the Southern Ocean that are collecting data continuously by drifting around the ocean. And currently there are actually hundreds of these floats out in the ocean that are collecting data live. But then what I did was I helped correct this data when it was incoming so that there wouldn't be any data drift is what we call it, where the sensors, since they've been out there for many, many years, they might end up having slight consistent inaccuracies that we can correct for to get the accurate data that it's collecting. Yeah, so that was my first internship. And my second internship, I worked in machine learning actually, where I was helping write a machine learning algorithm in order to detect or automatically detect sperm whale click sounds out of many sounds that are recorded at a hydrophone, so an underwater microphone off the coast of MBARI. So I know that was a lot of information to take in. Pretty much that is what I've been working on. So I hope that can give you some insight on how many different projects actually exist, right? How much opportunity there is to work in these kind of things. And not just what I do, but there's so many more amazing projects out there that sadly I can't get into too much detail, but I know, for example, artificial intelligence is now being used more and more within marine research even, and within research in general, such as improving the sensors, right? Improving these devices in the ocean to detect data better, to maybe detect what species is in front of them, or to automatically readjust what way they're going to not exhibit or encounter any dangers. Like many different applications like that, or there's also artificial intelligence being used in video detection to automatically classify different species, right? There's so much going on with computer science and marine research, and especially nowadays, it's really a growing field, and there's more and more need for computer scientists, for software engineers, in general engineers that are working in research, so that we can really speed the process and help advance what we're doing and really help understand and study the ocean, right? Even this will help us mitigate climate change effects, mitigate all of these negative things that are happening right now. Yeah, but then I also wanted to talk a bit about how can you get involved? Right? Because like, for example, I've been working on a lot of projects and I'm extremely grateful for this, but I haven't even graduated yet, right? I'm actually graduating next quarter. So I wanted to kind of motivate you through that even while you're in school, while you're in college, like you don't have to feel like you have to wait to graduate, you have to wait to get out and have a degree in order to actually do something meaningful. Actually, the way I got involved was just by talking to professors, by asking questions, being curious, right? When I went into it, I met some really amazing professors, and I would just go and ask them, what is your project? Do you need someone to write code for you? Do you need any help with, your project on a computational side, right? For me, that's what I asked because that's what I was interested in. Right, but for you too, like if you have anything you're interested in, I'd say go and try it, right? Find the people, ask questions. If you never reach out to them, you won't be able to get involved, right? So I'd say definitely just go for it. And, if you don't end up not liking a project or finding out that something's not for you, then that's also progress in finding out what you love and what you want to do, right? So I would definitely recommend, I think all of you are still in high school, but soon you're going to go to college. So definitely don't be shy. Actually, the first time I asked a professor, Dr. Tomanek, was my first quota at Cal Poly. I just went up to him like, hey, I'm really interested in what you're doing. Like, can I get involved with this? And through that, I was able to get involved immediately first year, right? So there's always opportunity for that. And even through reaching out, through working with my advisor at Cal Poly, Dr. Van Walter, that's how I even got the opportunity to work at Embari even twice. And so it's really amazing. So please don't be shy, don't hold back, but just go for it.
Should we take some questions? Rosalie asks, and please students, put your questions into the chat. How did you first become interested in STEM subjects like computer science and marine sciences?
Yeah, thank you so much. That's a great question. Honestly, my love for marine science, I don't really know where it came from. Ever since I was young, I loved the ocean and I loved studying how the world is changing, especially trying to help with climate change. So I was always motivated to help the planet in some way. So that's why I got involved in marine science and decided to go into marine science. But then computer science, I feel like for me personally, I've always just loved that kind of thinking or more logical things. So computer science came way more easy to me than anything like marine science. So then, because marine science was very difficult for me, but I also really love computer science, and I didn't want to just do one or the other, right? I wanted to combine them. So that's why I just went for both. And yeah, I'd say don't be shy to just go for multiple things too if you like it, like if you're interested in it, like it's definitely possible, right? And just try things, right? It kind of takes time to find what you like too. Like when I went into computer science, when I took my first class, I didn't know how much I loved it. But then by taking that, that's how I figured out, wow, I really love computer science and I really want to use this to do something meaningful. Mm-hmm. Yeah, I hope that answers the question.
Yeah. Carrie asks, what is the strangest thing you've encountered so far?
Oof. That's difficult. I'm trying to think. Sorry, I'm seeing all the questions come in. Strangest thing. Oof, I have a bit bad memory, so I have to think a bit about it.
Yeah, maybe we'll take another in the meantime. Stefan asks, in more detail, what kind of data does your team analyze?
Good question. A lot of different type of data. So project I'm working on, like my senior thesis project right now, I'm mostly analyzing the temperature data from the CTD. So pretty much it's that sensor just goes down to the ocean and then up in regular intervals. So that data I'm using to get an understanding of what is going on within the Cal Poly pier. And then we also have access to temperature data outside the pier being taken at a different sensor. And I've also, for that project, been working on satellite data. So pretty much satellites, they circle the Earth and take scans of the surface. And then while doing that, they collect a bunch of different data, including temperature or chlorophyll, salinity, like a bunch of different sensors. So I've been working also on using that data, the temperature data from satellites, and then visualizing it because they're all on different intervals and different timeframes. Right? But then it really, like I said, depends on what kind of project you're working on. Like my most recent one with machine learning, it was using raw audio data that was captured, and then we isolated sounds from the audio and just had a bunch of audio clips that we then used to train a machine learning model. Right, so yeah, it's a lot of data exists out there, right? So it really depends what project you're working on. Yeah.
And Rosalie asks, at the pier, has the data shown a lot of warming over the last decade?
Yeah, good question. So actually, because it's within the pier, There's always high frequency warming and cooling events, which is more what I'm focused on. So it's like within like intervals of maybe 13 hours on average is what we found. Temperatures rise really rapidly, and then eventually they cool down again rapidly. So it's more like these high frequency events. So I personally haven't looked at the long-term trends because I've been focusing more on these short intrusion events, these rapid warming events. But I know that many different papers, many different researchers have looked at that and have seen significant warming over the years. So I just can't personally attest to it because I haven't specifically investigated that at the Cal Poly Pier.
Mateo asks, aside from the data, have you seen direct impacts of global warming firsthand?
Aside from the data, actually, like meaning just kind of visually or through experience, I guess.
Or maybe bleached coral, for example,
Oh,
or
good question.
animals in decline?
I would say yes. I mean, the thing that always stuck with me the most is actually the changes in weather that we see nowadays. Especially because I grew up in Germany, which is why I have this weird accent. But actually, when I was young, there was a lot of snow, a lot of storms, like very cold weather. But then as I grew older, it almost never snowed anymore. And the weather was becoming more and more unpredictable. It just, you can really tell, like, even we've had warmer temperatures than ever before in Germany, like heat waves and everything that weren't explained before. But then also nowadays, we can see increases, like when you look at the ocean, there's increases in these tide or toxic algal bloom events, or what is known as red tides, where just so many fish just show up dying because of hypoxia, or like animals literally suffocate because of these intense chlorophyll blooms, and these are happening more frequently recently, right? But you can really, honestly, besides the data too, you can see the effects physically. And even I know recently in one of my classes, I learned about this, and I'm sorry about the barking. But in one of my classes recently, I even saw how the NASA headquarters in Florida, their parking lot actually gets flooded at high tide, which did not happen a few years ago. Right, so not even a flooding event, but just high tide, their whole parking lot is essentially underwater. So we can really see these changes happening even without looking at data, but the data just helps back it up and makes us realize how extreme these effects actually are. Like, we're reaching conditions that we have never seen before. The planet has never seen before for millions of years now. So it's really intense.
What was it like going from being a student in Germany to being a student in the United States? And did you notice any major differences in education?
Yes, definitely. It was kind of a culture shock moment. And yeah, I was like, you can still hear me, right?
Yeah.
I'm so sorry. Yeah, it was a lot of culture shock for me because really the education system's very different. Like, I know here there's the no student left behind policy, kind of like that. And it did make me feel like the curriculum, everything was very much simplified, right, in order to meet that requirement. But I think, though, my experience at the high school I went to, and my school is very different from a lot of maybe what you are experiencing at your high school at different places. Because, yeah, my high school was this little high school in the middle of Central Valley, and it was, yeah, I was just not used to any of it, like school rallies, everything, like the way even tests were conducted. I had never taken a multiple choice test before I came to the US. So the first time they put this bubble sheet in front of me, I was so confused. I just looked around like, what is going on? Like, what am I meant to do? Where do I put my explanation? So it was interesting. And honestly, I could probably talk about differences for a long, long time, but I'd love to talk about that a different time too, if anyone wants to reach out. But yeah.
Yeah, that's so interesting. Sophia is wondering, do you write code for specific data, or do you write code that can be used for multiple types of data?
I would say the way I write the code is usually for specific data, but it could be easily rewritten and applied to other data.
Huh.
Yeah.
And Grace asks, what is a typical day like for you?
Thank you. I mean, right now I'm a student, right? I'm still a full-time student and I kind of work on these projects on the side. So pretty much college life, right? Going to class, doing assignments, finishing my homework, pretty much like that. When I'm doing research or like, for example, doing my internship where it's full-time focused on that, then it's usually a typical work day. Like you go 8 to 5, right? You go to the office when it's not COVID, right? You go to the office, right? You write codes, have maybe meetings or get-togethers, lunch breaks. But I guess the only thing at Mbari that makes it very special is that you can literally just walk out on the beach or go around and look at, what are the other people doing? What are they working on, right? Or like I mentioned, just randomly go out on a boat or randomly go do some random project that they need help with around the office. So yeah, besides that though, for me, for what I do, it's mostly just writing code and analyzing data.
Mm-hmm. And Cameron asks, what type of code do you use? What languages do you code in?
Good question. A lot, honestly, depending on the project again. Like for example, the Arduino, I believe is C++ based. So it's more like a C++ type style of code. But then a lot of my senior thesis is working in MATLAB, which is used especially for large data sets and to visualize data. So it's really good for that. Not that good though for writing other practical code like machine learning, stuff like that. So for those kind of work, mostly companies prefer Python because it's so readily accessible. Everyone pretty much knows how to use it, and it's really well established within the research community. So I know Python's really preferred, especially within research. So I'd say if you're looking into what programming languages might be good also to learn, I'd say Python definitely. And then, yeah, that's the main one I'd say that I use just because it's so well established and it's free too, and you can share it with whatever researcher needs it throughout the world, essentially.
Mm-hmm. Stefan asks, were there any instances of animals compromising or possibly stealing your equipment? And what do you do to protect your equipment? And I know students are going to be brainstorming on this topic.
Yeah, I shouldn't give too much away then.
No, not too much.
Yeah, I mean, I'll actually ask about or answer the question about animals messing with it. Definitely that can happen. I've heard of some stories. I haven't directly worked with them, but for example, with the AUVs, I remember Bryna told me a story of how sharks tried chomping on one of the equipment. So when they brought it back, they found indents on it. And thankfully, the equipment was very sturdy. The AUVs built very sturdy, so it didn't do that much damage. But still interesting that a shark thought that our AUVs were something delicious, I guess, or something worth trying. Quickly found out that it's not delicious, right? It's just a piece of metal, essentially. But I know other cases too. Sensors usually are not influenced much because they're just stagnant unless maybe an animal eats them. I've never heard of anything like that happening though, especially since they're usually well attached. I do know once when I was out in Bari in 2018, we went out on a boat to operate an ROV, which is a remotely operated vehicle. So they're like these big vehicles that go down on a cable and then you control them in a control room. And they were trying to collect samples of deep sea sponges. And I don't know why it's always stuck in my head, but I remember they were about to collect this sample of this great sponge, and then came this fish and attacked the sponge. And then all the scientists were like, oh no, this is going to activate the stress responses. Like it's going to mess with our data. So it was a really funny experience. But yeah, so definitely that can happen.
Well, that wraps up our recorded segment, but thank you so much for sharing your work with us.